Hi, this is Paul Terpstra from Klover Products, and I'm out here on this beautiful fall day in our test range. And I just wanted to explain how we go about testing here at Klover Products. You probably have noticed that we've done a lot of polar plots and frequency charts, but that may not mean a lot to you, or if it does, you may be wondering how we went about capturing those. So I wanted to explain our test procedure, a little bit about how we conduct those tests, and hopefully give you a little confidence in the charts and graphs that we're creating. Now, the first thing that I want to mention is that we have a turntable that this camera is mounted to, and the microphone. And the turntable can rotate in 10-degree increments 180 degrees. So that lets us take measurements at various angles with various microphones and compare them to each other. As you'll see behind me, we have a self-powered speaker, a coaxial self-powered speaker, to make the sound that's emitted as focused and directional as possible. We've located that speaker 25 feet from the center of the turntable that our microphone is mounted on, and we pump pink noise into that speaker at a fairly high level so that it will overpower the neighbor's dog barking or a plane flying over, all those sorts of ambient noise that we might pick up and that you might be hearing at this point right now, as far as I know. So we pump pink noise through that speaker, and then we capture that pink noise on two separate channels, two microphones. The first is a reference channel. It's an Earthworks reference microphone. And then the second channel is our microphone under test. It may be one of our parabolic microphones, or it may be a shotgun, or it may be a competitor's parabolic microphone. Now, in order to gain as much confidence as possible in those signals, we take several steps ahead of time. The first is that we have an alignment fixture to align our turntable with the speaker so that the height and angle are all centered axis to axis, so the axis of the speaker is as close to possible of the centerline axis of the microphone. We actually use a laser, projected laser line, vertical and horizontal, to adjust the height and the angle of the speaker so everything is aligned. And then from that point on, every microphone that is installed on the turntable is aligned to that setup fixture, so that they're always in line with the speaker. Now, the second thing that we do is, before we do a test, we do a calibration run. And what that entails is we have two identical microphones, as identical as we can find, and we put one in the reference position and one in the test position. Then we take a measurement and store that. Then we take and reverse the microphone positions. We don't change anything else. We take the cable that was on the first microphone, put it on the second. We take the cable from the second, put it on the first, and change their physical positions. So if there's any inaccuracies brought about by the cabling or amplifiers, anything in the environment or the system, we will know what that is, and we average those two curves out and subtract that curve from any test measurements we take from that point on. So that should take care of any inaccuracies, whether it be cabling, amplifiers, etc. Both of those channels are taking into a Sound Devices Mix Pre 3, a very high quality audio interface. And then from the audio interface, they go into the smart audio software. That smart software then has a transfer function that is comparing the test microphone versus the reference microphone. So every mic that we test is compared to that reference mic, so that we're not bringing in inaccuracies based on one setup versus the next setup. Again, we're trying to do everything possible to make these tests accurate and repeatable. Our tests so far have shown that we can do the setup a week later, 2 weeks later, and get almost identical results. So once we have that curve, that is the comparison of the test microphone versus the reference microphone, we take that into a huge Excel spreadsheet, gather all the data for the different frequencies and at the different angles, the angles of the microphone compared to the angle of the center line of the speaker. So with our turntable, we're rotating the microphone and capturing a curve at each angle. That is how we create the polar plots. It also lets us compare microphone to microphone. We can also compare on a parabolic microphone what is the ideal position of that microphone relative to the, let's say, front face of the parabolic. So if our theoretical focus point is X, we take our curve at X and X minus an eighth and X minus a quarter, X plus an eighth, X plus a quarter, so that we can verify and understand how those frequency curves change as the position of the microphone element changes. So all that is said to hopefully give you confidence in the test data that we are presenting to you. We've done, like I said, everything possible to make it as accurate as possible. We're not trying to be biased. We are trying to be as fair and accurate source of data as humanly possible. In all the years that we've been in this business, we've never seen polar plots provided by other parabolic microphone companies, and we wanted to make those available so that people knew what they were getting when they purchased a product from us, and also so they could see how it compared to other microphones. So again, we hope that you'll take a look at the test data that we have presented and maybe compare it to a microphone that you're currently using. Now, the last thing that I wanted to say in wrap up is that people always ask us, well, how does it sound when something is recorded through a parabolic microphone? And I just wanted to let you know that this entire video has been recorded with a Klover mic 9-inch parabolic microphone. Now, we are here in an open space where it's normally used, so it will sound a little different. You'll get a little more echo when you're trying to shoot indoors, so you need to be careful with your positioning of the microphone to avoid parallel surfaces and things like that to reduce the amount of echo. But I think you can see that the sound of the parabolic microphone is very comparable to a very expensive shotgun microphone. Again, Paul Terpstra from Klover Products. Please subscribe to our channel, check out the website, and keep an eye out for new blogs and microphone comparisons. Thank you.